Now, our lesson is 10.7 is talking about areas of circles and sectors. We said yesterday that our objective from this lesson is to learn how can we find the areas of circles, sectors, and segment of circles. We started with the area of circle. We said that the area of any circle is by r squared. So I need to find the radius, square the radius, multiply it by pi, then I will find the area. Today now we will talk about a sector of a circle. Let's learn what is the definition of a sector and what is the area of the sector. Now look at the circle here. A sector is a region bounded by an arc of a circle and two radii to the arc endpoints. So if you have the circle here, so if you have the circle here now, this is the center of a circle. This will be now the radius of a circle. Now yesterday we talked about the arc. An arc, if I'm talking about an arc, I'm talking about this curve that connects between these two endpoints. The sector is an area shaded, this region. This area is between an arc and two radii in a circle. An arc and two radii in a circle. Now you name a sector using one arc endpoint, the center of a circle, and the other arc endpoint. If you want to name a sector, you will say, as an example, here you have A, B, C. So to name the sector, you will say it is one. You use one of the endpoints, the center of the circle, and the other endpoint of the circle. So this is the name of the sector is ABC. Now, as we said yesterday for an arc, we said arc, it is a part from the circle. An arc is a part from the distance around a circle. And here also the sector is a part from a circle. So if I want to find the area of this sector, I need to find the ratio for which this sector to the circle. Is it half of the circle? Is it fourth of the circle? Times the area of the circle. So to find the area of a sector, I need to find the ratio or the fraction where this sector to the whole circle times by r squared times the area of the circle. To find the fraction of this sector, as we said yesterday, I will find the measure of this arc AB to 360 times by r squared. So here, if you want to find the length of an arc, length, it's mean parameter. So I will say it is the measure of an arc, as an example, AB over 360 times 2 by r. This is to find the length of an arc. But if I want to find the area of a sector, I will say the measure of angle AB over 360 times by r squared. Here by the parameter, here times the area. Now, this is, I will repeat, this is the arc. The sector is the shaded area. This is the difference between them. The arc is the outer side on the circle, which connect between these 2 points, but the sector is a shaded area. This is how can we find the area of the sector. Let's have this example here. What is the area of a sector JPH? Leave your answer in terms of pi. So here now I need to find the area of a sector. So I need the measure of an angle JPH of that, not angle. Of an arc JH over 360 times the area of this circle. What is now the measure of an arc GH?
72.
72, thank you. So 72 over 360 times by r. What is the radius of the circle? 50. Thank you. So now 72 over 360 multiplied by 15 squared. It will be 45 by, and the unit is centimeter square. So this will be the area of a sector of a circle. A circle has a radius of 4 inches. What is the area of a sector bounded by 45 minor arc? Leave your answer in terms of pi. So here also we have a circle. The radius of this circle is 4. What is the area of a sector bounded by? As we said, the sector is a shape bounded between 2 radii and an arc. So this is my sector. The sector bounded by an arc, which is its degree measure is 45 degree. Find the area of a sector. Now, the area of a sector is
45 over 360.
Yes, the first we said the measure of AB over 360 times by r squared. Yes. Now AB is 45. Now what's the radius of the circle?
R squared.
4 squared.
4 squared.
Yeah. So
Just 16.
It's
45 over 360 times 16, it will be 2 by inch squared. So the area of the sector now is 2 by inch squared. Now, is it clear?
Yes.
Okay. Find the area of the circle. To find out the formula of the area, as we know, it is pi r squared. So if I want to find the area, I need to find the radius of a circle. How can I find the radius of a circle? Using what?
I can say 2 pi r. That means we're going to divide by
Yes.
2 to get
So I will use the circumference of the area to find r. We all of us know that the circumference of an area is 2 by r. Then the circumference is 26 by equal to by r. By cancel by. So 2r equal to 26. So r now it will be 30. Now we will put here, we will suppose now as r at 13. So by times 13 square will be the area. 1 minute, please. I'm sorry. So the area now here, so we have the radius 13. So we say it now by 13 squared to be the area of the circle. 13 which is 169 by. Is it clear?
Yes.
Yes.
Yeah.
Okay. Now let's do number 39. In number 39 here, in a circle is a 90 sector has an area of 336 by. There's a sector with a 90 degree. Its area is 36 by. What is? I want you to find the radius of the sector. Here now, we know that the area. Yes.
It is 169 by inch squared, right?
Ah, yes. Ah, sorry. So the area here now is measure of a sector. Let's name it as AB over 360 times by r squared. Now, the area, we said it's 360 by, it's given. The measure here is 90 over 360 times by r squared. I need to find now the radius of the circle. Then 90 over 360, let's simplify it now as 1 over 4. So 36 sorry, by is by r squared over 4. Okay? Is it is 36 by is by r squared over 4. Then I need now to find by 4. So 36 times 4 by equal by r squared. Let's by cancel by. So r squared, it will be, or you can say r, it will be the square root of 36 times 4, which is 6 times 2. So the radius, it will be 12. Let's say that 12 inch. Is it clear? Here now, you give me the measure of an arc. You give me the area of a sector. I need to find the radius. So the area is given, the measure of a sector is given, but the radius is not given. So the area is 36 by 90 over 360. I will simplify it. So 1 times by times r squared, which is by r squared over 4, equal 36 by. Times 4 by both terms, you will find that 36 times 4 equal by. 36 4 by equal by r squared. Then by cancel by, so r squared is equal to 36 times 4. So r, it will be the square root of 36 times 4, which is the square root of 36 is 6, and the square root of 4 is 2, so it will be 12. Is it clear?
Yes.
Yeah.
Can we do another one like it?
Sorry?
Can we do another one like it?
Okay, let's give me a minute. I want to search. Actually, there's no question like it, but I will make one from me. Okay, let's do this one here. Let's still know that if the area of a sector is 12 by, and the measure of an arc AB is 30 degrees, find the radius now. Here now, we will do the same. We have an area which is the measure of AB over 360 times times by r squared. Now, where's the area of a sector? It is 12 by. It's given. The measure of an arc AB is 30 over 360 times by r squared. Is it clear by now?
Yes.
Okay. Now we need to find radius r. Let's simplify it. Over 1, 12. So 12 by is 1 times by times r squared is by r squared over 12. Then times y times 12 times 12 in both terms to cancel this 12. So 144 by is by r squared. Then by cancel by. So r squared is 144. So the radius of the sector it will be the square root of 144, which is 12 inch as an example. Is it clear now, Yatawsa?
Yeah. Thank you, teacher.
Okay. Yeah. Now, now, what is the segment of a circle? Before that, if you have this circle here, what is the difference between the diameter and the chord?
The diameter passes by the center, but the chord does not.
Thank you. That's it. So this is a diameter and this is a chord. The diameter is passing through the center of a circle, but the chord here is the center. But the chord is not passing the center of a circle. Now, what is the segment of a circle? A segment of a circle is a region, the shaded region, between an arc and the chord. So the sector is between an arc and the radii of the circle. But a segment is an area shaded between the arc of the circle and the chord of the circle. This is a segment. This one we called it a segment. How can we find the area of the segment? They said like if you have this sector here, and if you find the area of the sector and you subtracted from this area an area of the triangle, you will find the area of the segment. This is a way to find the area of a segment. Here you have the circle. We said that each circle has a center, and this will be the radius of the two radii of a circle. Now this shaded part between an arc and the two radii, we called it a sector. And the shaded part between an arc and a chord in a circle, we called it what? We call it a segment. How can I find the area of this segment? They found that if you want to find the area of this segment, you have to find the area of this sector minus. Now look at this triangle here. This shape or this sector contains from it has two parts, the segment and the triangle. Here is the pink segment and the yellow triangle. So if you subtract the area of a sector from an area of the triangle, you will find the area of the segment. Is it clear?
Yes.
Yes.
What is the segment? And how can we find the area of the segment? The segment is different than the sector. A sector is between the arc and two radii, the two radii of a circle, but a segment is between an arc and a chord of a circle. Now let's do this problem here. Find the area of a segment of a circle. What is the area of the shaded segment shown in the right? Now look at this picture here. Here we have the circle. I need to find this yellow shade, the shaded part, which is a segment. As we said, if we want to find the area of the segment, you need to find the area of the sector minus the area of the triangle. So I need to find two areas now, area of a sector and the area of the triangle. The area of a sector, it is the measure of an arc AB over 360 times by r squared. The measure of AB is what? 60.
60.
Over 360 times by, and what is the radius of the circle here?
18.
18 squared. So 3 times 18, I think 54. Yeah. So 54 by, it will be now the area of a sector. This is how can we find the area of a sector. Now, I need now to find the area of a triangle. Look at this triangle here now. All of us know that if you want to find the area of a triangle, I need half the base times the height. Look at this triangle here. Where's the base of the triangle?
18.
Let's imagine it as 18. Okay. Now, I need to find now the height of the triangle. What is the height of the triangle? Is it known here?
No.
Or we need to
No.
find it?
We need
Teacher,
to
can't
find
we
that
use
by
the law of sine?
Yeah. Here now, look at this triangle here. I want to draw it down. This angle here is 60. So, if you look at this, let's draw this triangle. I forgot it how to be. Look at this triangle. It's not that, sorry. It's not right. Here it is 60, and here it is 18, and I need to find the height. So to find the height, as you see, this bisector is cut the 18, so it comes like 9, and I need to find the height. So I have the opposite and the adjacent. So which ratio should I use?
Yeah.
Thank you. So tan 60 is the opposite h over the adjacent 9. Then h, it will be 9 times tan 60. Tan 60, which is 1 over square root of 3. Wait, I want to see. 1 over square root of 3 or square root of 3? 1 over
Teacher,
square
is
root of
it square root of 3?
or 1 over square root of 3. I forget صراحة. Wait, sine 60 is square root of 3 over 2 over 1 over 2. Ah, yes, square root of that, yes. So it will be 9 square root of 3. This will be the height of the triangle. Now, after you find the height, you will put it here. Then you will find that the area of the triangle is 81.
9 point something, right?
Yes. So the area of the triangle here is 81 square root of 3. So this is how can we find the area of the triangle? So I have this triangle here, the area of the triangle. I have the area of the sector. After I subtracting them, I can find the area of a sector of the segment. So the area.
Teacher, can't I use the sine law, the law of the sine, to find the area of the triangle here? Won't it be easier?
Ah, yes, yeah, you can do. So here, the area segment is the area of a sector minus the area of the triangle. The area of a sector here is 54 pi minus the area of a triangle is 81 square root of 3. And with the unit, the inch or centimeter. This is a way how can we find the area of a segment. Is it clear?
Yeah.
Yes.
Yes.
Now, let's do this one now here. What is the area of the shaded segment shown at the right? Round your answer to the nearest 10. Here for this circle now, you know that the radius is 4 and the degree is 90. I want to find the area of the segment. So the area of the segment here is the area of the sector minus the area of the triangle. Now, the area of a sector, what is the here? Look here, it is the degree, the measure of an arc PR is 90. So I will say 90 over 360 times pi times the radius of the circle squared, which is 4 squared. The area of a sector, the angle 90 over 360 times the area of a circle minus the area of the triangle. Look at here now. As we said, if you want to find the area of the triangle, we need to find half. This is the base. Let's imagine that this is my base and this is my height. So, or no, that's not given. Let's use it as this is my base and this is my height.
This is a 45, 45, 90 triangle.
So what is the base here? It is 4. And what is the height?
It's also 4.
It's also 4.